So this is a supplemental video about depreciation. And in this video, I'm going to solve three problems from the back of chapter 5. These are the basic depreciation methods. We will solve a straight line depreciation problem, a sum of the years digits, or sum of the years depreciation problem, and we will solve a declining balance problem. Actually, it's all the same problem, just three different ways to solve it. I'm going to solve them on Excel, and then this the solved Excel spreadsheet will be posted on Canvas as this video is posted. So let me share my my spreadsheet screen with you, and we'll dive right in. If I can find it. And there we go. Okay, we're going to solve, as you can tell from the tabs, problems 5, 9, chapter 5, problem 9, chapter 5, problem 11, and chapter 5, problem 13. And you may or may not have the problems right there in front of you. Let me, I would show you the problem, but switching back and forth between the text and the cameras and all that stuff, I think we'll just stumble through that. So let me read you the words, the text of the problems, and you can see the data, the relevant data that are provided for each problem. A piece of equipment is purchased for $110,000. That's P, the cost basis, $110,000. And has an estimated salvage value of $10,000 at the end of the recovery period. That's F. Prepare a depreciation schedule for the piece of equipment using the straight line method, which we will use, with a recovery period of 7 years. There's N, the recovery period is 7 years. So we want to prepare a depreciation schedule, and many of the problems in the back of chapter 5 ask you to develop a depreciation schedule, and we will do that. Remember, the straight line depreciation has a constant depreciation each year, and that is based on the straight line formula, and that is the P minus F divided by N. So let's calculate that. P minus F, the cost basis, present amount, minus the salvage value, F, all divided by the recovery period, which is 7. And there we go, $14,286 per year depreciated for this. I see I need to add a couple of years in my table here, 6 and 7. The straight line depreciation each year is going to be equal to what's in cell E6. So I'll say $E $6. It'll be the same amount as I copy it down. And there we go. That's the depreciation amount each year. And we can calculate, although, well, it doesn't ask necessarily for the book value, but we're going, in each of these problems, we're going to calculate the end of year book value. That's EOY, end of year book value. And for the year 1, we start the year, is year 0. We start the year with a book value of P, the purchase amount, $110,000. And then at the end of the year, that book value has been decreased by the depreciation amount. So for the first year, it's going to be $110,000 minus $14,286. And our book value at the end of that first year is $95,714. Now for the subsequent years, it's we'll be able to build a formula that we can drag down that's easily repeated, since we're referring to the book value in the immediately preceding year. So this book value at the end of year 2 will be the book value at the end of year 1 minus the depreciation that we took in year 2. That gives us the book value at the end of year 2, $81,429. We can copy that formula on down and it will continue to calculate in that fashion. The end of the year book value minus the current year's depreciation gives us the new end of year book value. And if we have done this right so far, if we have done this right, when we copy this down, our book value at the end of year 7 will be the salvage value of $10,000. And if that occurs, we know that we have done this correctly. And here we go. I'm just going to copy this all the way down, and let's keep our fingers crossed. Well, looky there. We know that we will always, with straight line depreciation, you will always depreciate your asset to the salvage value at the end of the recovery period. Okay, that's problem 5.9. Let's now look at problem 5.11, which, as it turns out, is exactly the same problem, but now we're going to use the sum of years depreciation method. And I have calculated here the sum of the years already for you. And remember the formula, it's given in the book. It's the recovery period times the recovery period plus 1. So for this problem, it's 7 times 8, which is 56, and then all of that divided by 2 to give us 28. And if we were to sum up these years, you could see easily that they sum to 28. Now let's also remember our percentage, right? This is our depreciation rate or depreciation percentage that we will apply for each year. And that the formula for that is, remember, capital N, let me put it over here. The formula for the R sub M is the following. Let me pretty that up a little bit. It's equal to the recovery period minus M, which is the year that we're interested in, plus 1. So it's the number of years remaining is what that term is, divided by the sum of the years. That's the formula that we can plug in here to find out what this is. So let's just plug that formula in, and that will equal, and we'll take the recovery period, which is in cell D4, and because we'll want to copy this down, I'll say $D$4 minus the year that we're in, which is, I'll click on the year that we're in, and that will change, of course, for every year, plus 1, and then we'll divide that by the sum of years, and that is in cell D6, $D$6, because we don't want that to change also as we carry forward this calculation. 0.25 is for the first year, and that is, we could do that as a fraction. If you do it in your head, you know that the years remaining in the first year it's 7, and in the 7th year it's 1, right? We could take these numbers here and just reverse them, and it would be 7, 6, 5, 4, 3, 2, 1. And for each one of those, of course, we need to divide it by the sum of years. So in the first year, we have 7 years remaining. The sum of years is 28, and 7 divided by 28 is a quarter, or 0.25. We can calculate that all the way down, and we don't need all those decimals. Let's just let's leave it at 3. Maybe we need to leave it at 3 there. Okay, now the next column is the depreciation amount, D sub M, the depreciation amount. And what is the depreciation amount for each each year? Well, it's P minus F, that original purchase amount minus the salvage value, and that's how much we're going to depreciate over the 7 years. And then we take the P minus F and we take it times the depreciation rate, or the percent, for that particular year. And that means for this, in this case, I'm going to go ahead and do P minus F, although we know it's $100,000. Let's formalize this a little bit in case we change them. We might want to solve this for a different set of data, and if we build it this way, I think we'll be able to reuse this spreadsheet. $D, $3 is P minus F, which is $D, $5. And then we'll take that times the appropriate depreciation rate, and that will give us our depreciation in that year. As expected, since we're depreciating a total of $100,000 and we're depreciating 1/4 of it in year one, that's $25,000. We can copy that down, and this gives us our depreciation amount each year. Notice again, compared to straight line, as I discussed in class, this is an accelerated depreciation, in that, remember, our depreciation under straight line was 14,000 some odd for year one. Here it's 25,000. So we have accelerated that depreciation. It's a larger amount earlier in the depreciation life of the asset. Okay, book value at the end of the year, BV sub M, if you will. And we know that for year one, it's going to be the $110,000 minus the depreciation amount, 25,000. So our book value at the end of year one is $85,000, heading down to a salvage value of 10, right? The end of year two, I need to redo my calculation since I'm not jumping all the way up to P here. It's the book value at the end of the previous year minus the current year's depreciation amount. Now we're down to 63,571, and I can carry that on down to the end. And lo and behold, again, just like straight line depreciation, we end up after 7 years with a book value that's equal to the salvage value, the estimated salvage value of the asset. Now, let me interject here, and I'll mention this in class as well. Just because we have estimated an estimated book value out into the future, that doesn't mean that that's necessarily what that asset will be worth at that time. And there are tax implications if you sell it for more than that, or if you sell it for less than that when you dispose of your asset. That's another topic we probably won't have time to get into, but it is something that does affect it has tax implications for your organization. Okay, that's problem 11. Let's move on to problem 13, which yet again is exactly the same situation, except now we're going to use the 200% declining balance method, or the double declining balance method. We again start with a cost basis of P. The project life is 7 years. We have a salvage value of $10,000, and our depreciation rate is based on this formula for 200% declining balance, which is 2 over N. 2 divided by 7, and that gives us, well, let's get some decimals here. That gives us our depreciation rate each year. Now, whereas straight line depreciation has a constant amount of depreciation, double decline or declining balance in general has a constant rate of depreciation. So this rate right here is in D6. And that amount is going to be our rate, our R sub M, for each year of depreciation. Now you may think that odd. It's not odd. The main difference here is that if you add these up, it's much greater than 1, but we're going to apply these rates to the current book value, not to the original purchase price. And that is the big difference between declining balance and the other two methods we've examined, is that the calculations here, although you can see in the text there's a calculation you can apply to find the depreciation for any particular year, but generally the easy way to apply this is just to take the depreciation rate times the existing book value to get the current year's depreciation. Here we go, and let's see how we can do this. The depreciation in the first year is certainly equal to the depreciation rate times the purchase price, or the cost basis. And that's $31,429. Accelerated even more than the sum of years depreciation method. We're depreciating this even faster than we did with the sum of years method. The end of year book value then is equal to the purchase price minus the depreciation amount. Our book value then at the end of the first year is $78,571. Now, our depreciation amount for year 2 is equal to the depreciation rate, remember that's the constant, 0.2857, times the current book value, not times P. We'll take that times the current book value, and that gives us our depreciation amount for year 2 of $22,429. Our end of year book value then is equal to the end of year book value at the end of year 1 minus the depreciation amount for that year, for year 2, and that gives us a book value at the end of year 2 of $56,122. I'm going to do one more year here, and then we'll complete the table. Again, the depreciation amount will be equal to the depreciation rate times the current book value, which is the book value at the end of year 2, $56,122. That's a depreciation amount of $16,035. And our new book value then is the book value at the end of year 2 minus the depreciation amount in year 3, and that gives us an end of year book value of $40,087. I'm going to copy these down now, and we'll see how the depreciation amount continues to decrease, and at a fairly quick pace. And at the very end, notice that our end of year book value for year 7 is $10,435. So we didn't get to 10,000, but as you'll notice in all these calculations, the salvage value is never used. It never showed up in any of the calculations we did, or finding the rate or anything. The fact that it's even that close to $10,000 is happenstance. That is, it's nothing planned that it would be even that close. We could continue to depreciate this for many more years, just continue with the same rate, and we just kind of could continue to depreciate it and get the book value on down there, should we wish to. As I said in class, the book says that you must somehow get to the salvage value. That's not, it would be the case if you were using this somehow strictly for the government, but the government is going to have you do MACRs, and that's going to set a salvage value of 0, and you will get there using the method, that the MACRs method. So that's a different topic than these three. So we've looked at three problems. You'll have homework problems that are very, very similar to these. And these three problems cover the three fundamental, if you will, depreciation methods that are presented in the text. We have straight line depreciation, sum of years, which we're not gonna use sum of years much. You may get one homework problem and that's all you'll ever see of sum of years. It's not used very much in many settings anymore. And declining balance, which is used quite a bit and is the foundation, kind of one of the building blocks for the government's MACRS, Modified Accelerated Cost Recovery System method, which we discuss more in class. I hope this was helpful, and I hope that it will be helpful as you work on the homework problems that will be assigned.